Chris Anderson's work? Nobody? Not one person, two, three. Okay, cool. So Chris Anderson, I was always fascinated by this because he talks about how when technology comes out and it's highly disruptive, it goes through these four critical phases. So almost all big tech, when it goes through these, when it's highly disruptive, it will go through these phases. So he wrote a book on it. These images are snapshots from his 2004 TED Talk, so it's a long time ago. And I think Chris's work, as I understand it, was part of every kind of pitch, kind of VC pitch for a long, long time. There's some kind of criticisms of it, I think, back and forth. I'm not here to kind of debate the theory. I'm really talking about, I want to use this as a kind of backdrop around kind of the changes in technology that we're seeing today. So his theory was that every big technology is going to go through these phase shifts, right? It's going to hit a critical price. It's going to hit critical mass, right? It's going to disrupt other technologies, and then finally, as it gets kind of near to free or close to free, that's the long tail. But as technologies get close to free, they kind of create new markets. They change a lot of things. So that's the long tail theory in short. So I did a bunch of research over the past couple weeks and pulled a bunch of data in around as best I could using our friends, GPT, Bard, and just the internet. So I tried to conform everything in this chart, which is supposed to represent. So the blue line is CPU, purple line is GPU, and this is kind of cost. So I tried to conform it into terms of like flops, right? So floating point operations per second, which I know is not a perfect measurement of CPU to GPU, but regardless, I still think it's directionally correct. But you can see from kind of the beginning days, if you can't read the back, from 1960 up to kind of current times. Obviously the CPU wasn't very. There wasn't a lot of capacity in our CPUs back in the day, right? They're very expensive, and then over time, interestingly, at least on my graph, the year 2000 is kind of this inflection point where things dramatically changed. Kind of grounding that in a little bit of reality. So my first PC, which I bought in 1993, when I was working for a company called CompuServe, I guess I just looked this up, but it was around 70 megaflops, right? I don't know how many flops it had. I just used it. And I know for me, at least, computers felt very CPU constrained until recently. But that first PC was around $2,000 and actually cost me about 10% of my income at this company, CompuServe. So they actually had a PC payment plan. So imagine this, where we went out and bought a computer because they were so expensive, and they would reimburse you for it, and then you would pay them back over 2 years, right? So that to me was a really precious resource, this PC back then. But obviously it's highly antiquated, has been for decades. But the first iPhone comes out at 1.28 gigaflops, right? So massive orders of magnitude, higher in CPU and compute, in just a decade or so. And then now we're looking at these new, NVIDIA's, stock is on the tear, right? Because they're producing all these chipsets for LLMs and AI training. And I think this might be the H100. It's like 624 billion teraflops or something. Or no, 624 teraflops. So just massive kind of increases in compute, but yet you can see that the cost is kind of obviously gone down over time. All of this, I'm not going to bore you with a bunch of graphs. Really tried to kind of set the stage here that we've gone from scarcity to abundance. When it comes to compute, right? So computers, mainframes used to be behind locked doors. Nobody could access it other than the people that had this for the job. They were very controlled because they were a very precious resource. Shift to today, our cars today, modern cars today have between 1,500 and 3,000 chips integrated into them, right? Which is kind of mind-blowing. Deloitte's saying that cars in about 5 or so years, almost half the cost of a car will be because of electronics, not the car itself, right? But that's the kind of shift again from scarcity to abundance. Storage, same story, right? So I don't have a lot of details on this one. I didn't bother looking them up, but obviously we understand storage has got cheaper and cheaper. Ask Ben, he can cut you a deal of rack space, but a lot of stuff is enabled cloud computing between all the big hyperscalers, right? Because storage has gotten so cheap, compute's gotten so cheap, that we can now run these workloads in the cloud. Broadband, same theme, right? So you look at know, how many of you ever used a modem to connect to the internet? So I get some references in Europe, see how they kind of land with this audience. But so you know, when I had my first computer, first modem, I mean, you can see really poor performance, really expensive, right? And then over time, obviously, broadband got more available, right? It gets cheaper because demands increased. So you know, at this point in time, obviously, everything we have connected, right? So it's like basically everything we have is everything everywhere is all connected. All of, I can move that. Everything everywhere all at once is connected. Somebody get the reference? Yeah, maybe. I didn't.
Moving on.
So it's always kind of fascinated me ever since I heard about the long tail theory, because it's like, you know, what would happen when things get close to free? Thanks, Chris. To me, the best example of this, honestly, is like YouTube, right? So YouTube, you know, 5-10 years earlier would be useless, right? Nobody would watch it, right? It'd be like this projector that keeps on moving in and out for us. But now, and since bandwidth is so available, now it made all of these new companies, new services possible, right? So what do all these things have in common? Scarcity to abundance, high cost to low cost. But again, I want to shift to kind of why I feel like this time is different. One thing is kind of how do we, so I don't have a single graph for AI, right? So how do you measure the increase in AI capabilities? Is it investments? Is it patent filings? Is it new policy being proposed by the U.S.? I'd say it's really a challenge because obviously AI is not one thing, right? It's a bucket of things, and it leverages everything we just talked about, right? Between compute storage and bandwidth. So it's really hard to kind of chart what is machine learning, LLMs, artificial intelligence, whatever it is, on a single graph. But I would challenge any of us. Do we really question that it's not advancing? I would say it's advancing at a breakneck pace. So again, why is this time different? So I believe, and this is just these are Mike's thoughts. So feel free to challenge or question or validate, but I think the three major factors, it's really not about the technology. We technologists love to geek out about technology, but it's really about the interface, it's about inference, and it's about speed, right? That makes this disruption significantly different than disruptions of the past. I'll start off with interface. So never before have we seen an interface so intuitive. Right? We technologists tend to make things a little bit overly complicated. So if you were to imagine the kind of the human-machine interface prior to NLP, you might imagine something like on the left, right, where it's left. Something like that, right, or some skull cap or something. But in reality, it looks more like on the right, right? I don't think Aaron, I don't think Brian's here, is he? But so this is kind of a nod to Ryan in our first one of these meetups. He was like, I showed ChatGPT to my grandmother, and she just went to town with it, right? I mean, she could just type her and ask it a question, and it would answer, and she could type another question, answer. And I'm like, oh my God, that's so insightful, because it's a natural interface, right? So I think the interface is significantly, it's native to us, right? All you do is talk to it. I think this simplicity leads to a much greater increase in access, right? So interfacing with any kind of machine to date really required you to understand, even if you're talking to Siri, right? You still need to say, hey Siri, and then say things in a certain order, and then sometimes it answers you, but if you talk too long, it cuts you off, right? So even something simple like that isn't as simple as NLP. But if you look at this first white column, these facts can take it up again, but there's around 28 million software engineers or developers globally, right? About 4.5 million of those are in the U.S. You have an order of magnitude higher number of people that are using ChatGPT today, right? So you have 200 million active users on ChatGPT versus the number of kind of engineers, the people who could really talk to a computer and make it do something prior to ChatGPT. Again, it's not the same thing, I get that, but let me just think about that for a second. I think that the number of people on the right-hand column is 1.6 billion people that globally depend upon a computer to do their job day to day. right? Which, again, I'm not comparing apples to apples here, but you know, the 1.8 billion monthly visits that ChatGPT gets, it's kind of a mind-blowing figure, right? So if you think about, again, just trying to build this story around the interface drives simplicity, that simplicity drives adoption, right? And then with that adoption, I think then you'll just see, I think this, to me, I think will happen, you know, a much greater diversity, a much greater participation from people with different domain knowledges, bringing their problem-solving skills, you know, to technology, right, today. So if you've heard of the, you know, let 1,000 flowers bloom philosophy of Google from an innovation perspective, I think we'll see kind of a, you know, let a billion flowers bloom, right? And granted, not all the ideas will be good ideas. Some will be bad ideas, junk, scary things. But I think, for the most part, I think we'll see a great deal of innovation over the next 3 to 5 years. The second thing is inference. So remember, it's interface, inference, and speed. So it feels a bit uncomfortable saying this. So my background is I led some data strategies, built out some data platforms, built and led data science teams. But one thing I saw over that time, or my history, and my experiences, I think I kind of had this feeling for a while. Now I think it's really dead, but I'll be nice and call it retiring. I think the single source of truth is going to be retired, and you know, kind of get into that a little bit why. But it's you know, I think companies spend millions of dollars trying to build this fact and dimension conformed thing, right, that they can ask it a question and get an answer from immediately. But it just takes so long to get there, right? It takes 1-2 years to spend millions of dollars on it. I've just seen it too often end up in it where the business is like, hey, thanks, but can you just give me access to the data and let me do my thing? So I think that's an influence we're going to see going forward, and part of that's because of inference. By inference, I mean, so if I asked, so Alexandra, my wife, she's scary because I talk to these LLMs too much during the day. So I was I'm going back and forth with Bard, and I said, hey Bard, how much is a gallon of milk? And it gave me a price. Actually, it gave me 3, kind of one East Coast, one West Coast, one Midwest. I said, interesting, where did you get that data from? And it said, I got it from these 3 sources, right? So 7 sources. And I was like, well, if you had 3 sets of data, then how did you give me a single amount? He's like, well, I added them up and averaged them. I'm like, okay. Right, so for me, for that answer I needed, what was a gallon of milk, it was perfectly appropriate, right? So kind of building on, the Seth Godin quote of, I'd rather have a quick and dirty answer now than a perfect answer that never comes. Right? And I think just in my experience, I think a lot of business leaders would rather see that kind of approach versus kind of waiting for the perfect thing to come years down the road. Kind of building on top of that too. So and again, not everything. You can't go, you can't report your company's, kind of profit loss to the SEC, through LLMs, right? That's not the idea here. I think some things have to be by reference, right? So if I'm buying that gallon of milk from your website, then I want to know exactly how much it costs, right? I don't want to guess, right? I don't want to, you tell me it's $4.50 and then I paid, $5.25. It's got to be precise. But I would argue or kind of throw out there, I think a lot of things in a lot of companies, 20% of it can be really, really precise, but a lot of it can just be answered through inference, right? Through, I think, through inference. I'll leave it there for a second. So I'm not saying, data warehouses are completely dead. I think they do serve a purpose. So if you're, aggregating data out of your transactional systems, like your commerce system, your customer product, whatever, ERP, you can aggregate the data for things like contract compliance, SLAs, blah, blah, blah. That makes sense. But if I'm a customer service rep sitting on a customer who's like, hey, where the heck's my order, right? If I get the system that they've already seen on the site, but somehow I get some other information from another source that's maybe static or not conformed into my data warehouse, and I can use that to interpret and give the customer a good answer. Well, why wouldn't I do that, right? Or if I'm a sales rep saying, hey, help me prep for my customer visit today. Here's who I'm going to go visit, right? Go crawl the the emails we have on them. Go kind of go dig into the communications. Tap into the digital marketing team's little proprietary database. Every company has all these little proprietary databases. But go kind of go across all these things and kind of give me the best answer you can give me. Which I think I don't want to get too technical, but RAG architecture is kind of one of the architecture patterns that AI brings to the table. It's an augmented generation kind of retrieval mechanism, right? Where so you can give it some more current data or data about your company, so it gives you a smarter answer, but still leveraging the large language model to kind of cascade across all those data sources and bring back information. Yeah, or if you're the CEO, right, just ask it a question. Give me an update on your company's KPIs, right? So how can it react to you? Give you some information back that's useful enough, for you. Right? Again, you don't have to wait 2 years for a data warehouse to be created. This is not without problems, right? So I think current companies are really concerned because it's like, hey, I don't want to just give all my data to this LLM thing. I don't know who has access to it, or who's going to see it, or where it's going to go. So obviously, I think the architecture is going to be built out where, you're going to need some kind of security in there. I think a little bit of a nod to, Mantium and Muto, where they're, really looking at data security and security around data going in and out of these LLMs in a very interesting way. I think it'll be very key. So companies like that, startups like that, where it's really the tooling around this kind of approach still needs to be mature, but these are 2 local companies that are attacking it today. I think with that though, I believe that companies will move towards this kind of this generalized bespoke model for my company, right? So train it on my data, keep it in my sandbox, don't let anybody have access to it. Again, if you do that, you still got to make sure that people can't see each other's salaries and all that kind of stuff. But I think that'll be where the future's headed. I think then you'll see little things like maybe little vertical models being built out for finance and inventory and other things, right? So you can kind of iterate to the smarter future, if you will, over time. But I think inference will be much more part of our enterprises and kind of how we get information back out of our systems in the future versus this old world where we kind of conformed everything into one centralized resource. I really believe like generative AI is going to be for the modern enterprise what electricity was to the the industrial revolution, right? It's kind of this influx of acceleration of outcomes, right? I think we'll see things take off. So this is like a rag example, right? So if you ask ChatGPT, I don't know if everybody knows about Lionel Messi, right? So Lionel Messi was one of the world's most popular soccer players, right? We're playing for a team in France. So if you ask it, kind of, hey, where does Lionel Messi play? It's going to say, well, Paris, Saint, is it Germain? Yep. Okay. I don't know. But a team in France. But if you kind of give it additional information where it's like, hey, he actually came to the U.S. MLS, he's now playing for Inter Miami, right? Well, then now can give you a more appropriate answer. And the final kind of reason I think it's going to be different this time around is speed, right? So again, kind of bringing it back to the long tail theory. Again, critical price, critical mass, other technologies nearly free. So I think on the critical price front, to me at least, ChatGPT and ChatGPT and BART are either free or kind of close to free, right? So to me they've already kind of achieved this first kind of inflection point. But Google, Amazon, and Meta are investing billions, right? Kind of, and I got this quote from Chamath Palihapitiya. So he's like, all of these big tech companies are using all of their resources, right, to kind of completely scorch the earth on the economic value of large language models. So what he's saying there is, they're all investing very heavily in it, which is great for us because they're going to make them, continue to be very close to free, very available, in kind of part of all of our different products. So. Anybody get to join the battle reference here?
Yeah. Mm-hmm.
My son's 23, and he's like, is any of your audience under 30 because they're not going to get it? It's like, I think so. The second one, critical mass. 200 million users, drop the mic, we're done. They've already kind of, ChatGPT's already crossed that threshold. Another technology that gets disrupted, the 10 blue links. I think we're all, if anybody's using ChatGPT or BART, I think we're all now tired of it. I'm really, now when I go back and just do a Google search, I'm like, stop trying to make money off me, right? So it's like everything's an ad, everything's trying to be monetized. So I think, that really changed the game for search. Again, I'm not sharing anything you probably don't know. And then free and nearly free, I think, again, it's already there. So the point of this, from a speed perspective, I'm saying is that, while it took decades for these other technologies, like, 100 years basically, or multiple decades for a compute to get to the point it needed to be. Storage, 7 to 9, broadband 4 to 5. So it took a long time for these disruptions to happen, right? We had a long time to adjust and accommodate and get comfortable with them. I don't think we do this time, right? I think it's kind of sped through these kind of these inflection points. And we're at a point now. It's like the adoption is going to take off, and so to me, it's going to jump on board. So that's why, from an inference perspective, inference and speed, I think this time is going to be different. Again, not about the great technology that's underneath all that. I think it's great stuff, but I think it's more about kind of what you can do with it. That to me is more interesting. Consequences, barriers, and keys to success. So, consequences. If we're sharing, I don't know, we share these? We did it last time. So the last side of the deck, I got a bunch of references. So this McKinsey paper I read, they were talking about winners and losers of LLM coming out. So they're saying it's going to be, healthcare, transportation, and warehousing. I think the stat was, I fell off the slide, but the stat was like, I think they see a 25% increase in healthcare STEM workers over the next X years getting on the horizon. So there you go, include health. So you guys want to go. Losers, customer service, sales, and food service. And again, I can't remember all the reasons behind this. I do believe that it's gonna result in a much more efficient workforce. A lot of people are throwing around this 30% metric. I don't know. I don't think anybody's really measured it yet. But if you remember back, I don't know how many years ago, but we used to talk about when digital companies like Amazon and others were out, kind of being created. They're saying how much more effective these digital companies are going to be, how much more efficient they'd be, because they don't have all these people doing all these manual things. So that, imagine that the analog companies, now the digital natives, now the AI natives. So you create a company today based upon this technology with the automation that comes along with it. I believe it's going to be much, much more effective, and you'll see kind of a wave of these kind of blockbusters kind of falling by the wayside for companies that don't adopt. So speaking about not adopting, so barriers, humans, right? So we don't like change a lot. I think there's a lot of people inside a lot of companies who are afraid of it taking their job. They don't want to embrace it. So I think just human nature will kind of slow adoption a little bit. To me, I think big moats. So if your company is protected by a big moat, whether that's regulatory or IP or you have market dominance, I just think big moats create complacency in companies, right? Because you don't have anybody threatening you. So I think those companies, with the amount of inertia they have to overcome to adopt new technologies, they'll be slower to adopt. But I do believe that the proverbial frog in the pot, right? The water's starting to boil a little bit. I think the mental models need to change. I think the majority of the workforce still thinks about things in we call it kind of spreadsheet thinking, right? So they're still trying to problem solve in that approach versus thinking about how can I leverage these language models to solve problems for me. Again, it's not about the technology. I've been guilty about this. I've been guilty of this in the past too. So something so cool and so neat. I was telling people, a long time ago when I learned multi-threaded C++ coding way back when. I mean, everything was multi-threaded, right? Why? Because I just thought it was cool, right? It didn't have to be multi-threaded. It was like, look at that, I made things multi-threaded, right? And I think we as technologists get excited about the technology, we get excited about AI, we get excited about this, the understanding it, being smart about it. And to me, that's kind of a distraction, right? So it really should be focused about what problems are we solving. Keys to success. Data is still your new oil. This was a saying, probably about 9 years ago. When I think the data, people were finally kind of getting kind of the data, the value of data. I'm an advisor to a couple companies, and I keep on. It's amazing how it's like, oh yeah, I mean, talk to them, you see what they do, and like, my goodness, you have like an amazing data set, right? You can do so much with that because you're like the only one with this population or something. Are you protecting it? Do you have vendors that are just giving it to? Like, I don't know, right? I'm like, oh, you really need to put a wrap around that thing. So I think because so if you think about it, if every LLM is trained on the same data, then they're all the same, right? There's no differentiation, right? So how can you be differentiating as a company if you don't protect and build that bespoke data set? So I think that's still true. And again, people kind of forget about that and think about the tech. Data's still crucial. Speed and empowerment through autonomy. Really uncomfortable, right? So these powerful things, we like to centralize and control them. My advice is how can you empower your teams, especially the teams closest to the customer. They're going to understand the customer's problems better than the centralized team will. So how do you empower them? Put guardrails out there, but how do you empower them? Give them autonomy to solve problems. Diversity through thought and innovation. So again, I think one of the exciting things over the next 3, 5, whatever years we'll see is kind of how, who thinks of this great idea that I now love, right? Because I think now that this technology is available to a lot more people, I think that diversity of thought will bring more interesting ideas to the table. I really think product thinking is important too. So what problem are you solving? Who are you solving it for? What's the value of solving that problem, right? Understanding the customer, right? Having empathy for that customer as you're building something out. Don't get distracted. Don't, if you're 5 levels away from the customer, then get as close as you can to them to understand kind of how this model that you're tuning or building is going to benefit somebody. Probably not speaking to anybody in this room, but I think the right government policy in place at a national level. So if you think about countries as everybody's pursuing this, right? I think some countries will be better than others around you need to put guardrails in place to protect your citizens. But at the same time, I think you need to put policy in place to incentivize innovation and build out and that kind of stuff. And I think the country that does that will win. And personally, I think too, if you're in a leadership position, have a strong bias towards practitioners. There's a lot of theorists out there, I think, that are talking about generative AI and such. And I think the challenge I see is a lot of people lack the battle scars that come with learnings, right? So if you're out there talking to a company, just ask them, hey, what's your background? Have you implemented this stuff? What did when did you fail? When did you struggle? Because I think that's really important if you're going to take advice from another company or another person. So interestingly enough, so again, I started with the long tail and Chris Anderson, TED Talking in 2004. So I went to his blog, and one of his last posts in his blog had this quote I thought was really poignant. It says, "Technology wants to be invented, and we are almost powerless to stop it. We are hardwired to create the future, be it good or bad. Invention is its own master." He wrote that in 2009. So it was kind of just, I don't know, to me it was kind of interesting. It's like I've been using this guy for research, and so it's obviously still powerful today. He's saying good or bad. This is why really I think, I'm really as optimistic as ever, because I think the problems that we have to solve are pretty much infinite. I've seen over my career, it's like I remember early on, it's like, well, you software developers are going to go away because we're not going to need you pretty soon, right? But we just keep on expanding the number of problems that we're going after, right? So I think that domain is pretty much infinite. And then this convergence of, I'll call it generational innovations that are happening in the removal of constraints around compute, storage, bandwidth, the natural language interface, access to all this AI technology, that I'm sitting here saying, I think this is the best time to be in technology. That's pretty much what I have. I wasn't really timing myself. I think I went about 30 minutes. So if you want to open to questions, or what do you want to do? Any questions? Why did Jeff show up so late?
It's not often we get a head fake for a presentation, so what made you, everyone in the room, oh look, Jeff is here, look at that. What made you change your presentation / go down this path? Like what inspired you to do kind of what you're doing now? Is it, I'll let you answer.
I mean, to me, a lot of the content's the same, right? But as I was doing the research and building it out, I'm like, man, it's a really exciting time to be alive. As I was thinking about myself, engineer for about the first decade, I'll just say architect, leader, data guy for the last kind of decade. I've never had access to the stuff that's available today, right? I was always kind of scraping and grinding, trying to solve a problem. So I just built an app. I just built an app so that'll, you text me a URL of your soccer schedule, I'll scrape it, I'll dump it in a database, and then have a text interface to, hey, when's my next game? right? And it, you know, you can give it prompts like schedule or game that it parsed for, but if you do anything open-ended, like, hey, who do I play next week, in the form of a sentence, it'll dump it over to an OpenAI API, and give you back an answer, right? And I told it to be a little bit salty, so it's kind of common. But to me, it's like, you know, I had to learn Python, I had to learn all stuff, but you know, with the tools today, it's like, you know, about a week and a half, 2 weeks it took me to build this app, right? So, I mean, I haven't coded in 10, 15 years, I don't know. So what are you know, what are you guys gonna go out and invent now that this stuff is available? I guess it's kind of what, now building this, I'm like, you know, the opportunities are just endless, right? So I think that's what I'm excited about. I'm excited about, you know, kind of energizing this community, you know, Central Ohio, to go out and do stuff right now, because I think the barriers have been really reduced. So whether they're talking about disruption, which is kind of scary, it's like, hey, right now's the best time to be in tech.
So one of the things that I've seen a lot is kind of AI's disruption, specifically in the education and teaching space, much the way that YouTube, like Khan Academy, kind of changed a lot of that. It seems like these large language models are turning into making tutoring, if not free, mostly free for most subjects. So kind of, do you have any predictions on what you think is, do you think that that is going to level the playing field more, or is it going to actually make it more uneven, where some people take advantage and move ahead even faster, and some people just don't kind of learn? Do you think it's going to get kind of more even where everything still quickly, or more uneven where some people are just so far ahead because they've had a personal tutor and coach 24/7 for like 5 years?
No, I think you're right, and it's concerning from the, you know, kind of haves and have-nots. Now, I think it's great that it's pretty open and available to, you know, just about anybody. If you have a computer and an internet connection, you can get to it. But I think it's just like, you know, through COVID, right? When if you were in a household where you didn't have access to a computer or broadband, I mean, that's a huge concern. I think, you know, population's falling behind is a huge concern. I think it opens up to, you know, other opportunities. I really think, you know, every solution kind of opens up new problems, and those new problems, I think, become the next, you know, kind of source of the next innovation. Yeah, I don't know if anybody else has an opinion there, but everybody, I think, you know, predicting the future, everybody's always wrong, right? So, but it'd be good to hear if anybody else has thoughts on that, or anybody else is in education, or maybe looking even at technology in education.
Yeah, I personally think it's the environment, it'll cultivate it. So like, I feel like if a country basically fuels innovation, the fruit will come from that. If they don't, nothing will happen. It's like, if you see someone next to you using this, you want to use it.
I will also add that as somebody who's worked in education, I do really see a lot of opportunity to scale tutoring in a way that hasn't really been available prior. That being said, I would currently limit the use of AI to tutoring at this point. I think actual instruction is something where new ideas need to be introduced to people who are learning, because they might not necessarily know how to find those ideas within an AI. But in addition to that, the AI can still get things wrong or mislead students who are still trying to learn, just given the hallucination problems that we end up seeing. So I would definitely let my students use it, but I would also have small, fairly inconsequential quizzes to make sure that they actually got the correct information prior to any major exams or something along those lines.
Yeah, you're making me realize one thing I believe in, I didn't have in my materials, I'm realizing, is you got to have a human in the loop, right? You
Yeah.
don't want to let this stuff loose on anything. It's like it hallucinates constantly, right?
Yes.
I mean, I'm like working something. It's like, well, go click the debug thing here. And I'm like, I spent an hour looking for a debug option. I went back and like, there is no debug option. I was like, oh yeah, you're right. It definitely gives you wrong answers.
Have you tried regenerating 4 times? It's like current, 3 regenerates is about.
Well, it was actually that first graph I created, because I was going through a lot of kind of historical, you know, kind of mining of data, and it literally went 10. I've never seen it. It was like 10 or 12 times. This is embarrassing. And it just got more and more. Finally got it done, but I think I saw a hand.
So piggybacking on the questions, do we feel incorporating AI into our learning in our younger generation, are we doing justice to their thinking? Are we then going to follow, are we going to start looking at neurons that's not going to be used anymore? You're going to get an answer, we want to have them problem thinking, but then what kind of service are we doing to our younger generation if we keep incorporating AI? Right now, as you can see, like, obviously for some of us decades back, we still had to do our mental math. Then came the invention of calculators. Then came the invention of digital. And now, if you're going to get an answer right away, how do we enable, have folks been thinking, should our learning change? Should the way we think change?
Your opinion?
Yeah, I definitely have an opinion.
I think it has to.
So I would imagine, I wasn't alive when the calculator was invented, but I'm not sure if anyone was here in this room, but there was probably quite a bit of people that also had the same exact worries about, what is this doing to our children? Now they can just type on this little device and they can solve these problems. But did that stop all of us here today learning about technology and thinking critically? I don't think it did. And I think there's this awesome app called Wolfram. There's like a plugin on ChatGPT called Wolfram, and they have a website called Wolfram Alpha. And you can pay for this Wolfram Alpha, like a premium version, and they can step by step walk you through, high level mathematics. Everything that I wanted with machine learning, logistic regression, anything, multiple linear regression, multiple regression, all these things. They can walk me through these concepts, and I think that's invaluable. And you can also ask LLMs about new ideas. It can give you that pushback. Kind of what you were saying. How do they know what to look for? I feel like LLMs really opened up my ability to just type in and brainstorm and use it as a feedback.
It's a great learning tool. It's a great learning.
Yeah.
Perfect.
But you got to verify what it says.
I think one thing it does is it fosters creative thinking, and it allows people who might be more creative minded rather than technical minded to add more technical ability to their creations, and therefore create better art or better whatever it is. Because you can, for me, for instance, I'm a musician, I'm a creative thinker first, but I can utilize ChatGPT to help me create things that I wouldn't have been able to before. Now I can create applications a lot quicker than I would have been able to, before the inception of ChatGPT. And so, yeah, that.
Hi, I just wanted to introduce myself. Probably half the room knows me, but half the room doesn't. My name is Rainy Das. So I just want to share a story because you talked about the single source of truth. And I think that defines what that is, even if you have different sources, right? So sometime back in my office, it was just newly built. I got something in the mail, regular mail, with a postage stamp from Maytag that I had to call some 1-800 Maytag number, and they have some kind of a recall of some, hot wire, and if you call this number, they will send a repair person in, right? So I call this number, and an IVR comes in, which is the original ChatGPT if you think about it. The IVR says, if your name is John Doe, say your name, spell your name JOHNDOE, John Doe. And so it comes back, what's your name? So for a person from India, my first name is 4 letters and last name is 3 letters, which is pretty good, especially coming from India. But so anyway, so I said Rini Das, RINIDAS, and it comes back with a response saying, did you say if your name is badass, press 1. If your name is not badass, then press 2. So my point to the story is that again, it is the quality of the data that is put in that ChatGPT and everything is searching. And with respect to Wolfram and all these kinds of things, you have to trust the source to know that nobody has messed with that source and there's no bad, ill information. And the reduction of the noise is very, very important, especially if it's not a very deterministic model.
Yeah. So I think-
Prompt injection is the thing, right?
Yeah, that's,
I think, Rainey, we all know which number you press. You press 1?
I'm sorry. I just wanted to mention, I think that the fundamental paradigm of education just in and of itself needs to change. We have students now who are in schools having to do a lot of memorization, still very rote memorization. We have this sort of model from the industrial age that isn't really transferring well to what we're getting into in our society. Meanwhile, we have this technology, while not fully always perfect or accurate, we have something that can provide an opportunity to really explore creatively new ideas, something that will not lose patience with the student, which I think is extremely important, and something that can allow students to creatively express themselves and learn through that expression, almost as though they're working with a companion or someone at their level or someone who can get to their level. So the question I would like to pose as a response is, given all of that, what benefits do we potentially lose on? Are we doing a disservice to students by not introducing them to this technology? I just think the pros at this point would outweigh the cons.
Thank you. I think just in response to that, it's really important if you're comparing two types of care. One is our education system, one is our healthcare system. So both these two types of care are the delivers, folks who are delivering that care. So for example, if a teacher is incorporating AI, he or she needs to understand, verify, validate the source of truth so that you can do it. Likewise, same with the providers who are, I just saw a recent article saying that AI can give a response to your test result in the next 30 seconds. While we know there is still so many faults, even with our digital, do we completely rely on AI, or is it the responsibility of the doctor to review that information before it gets posted out?
Absolutely.
So I think it's that delivery of incorporating AI is something that we have to look at.
Absolutely.
Maybe one more. I saw Jacob, sorry, I'm gonna go ahead and stand up.
Yeah, I was just curious, with your background in product, what do you think about the business model of ChatGPT, open sourcing first and then monetizing after? Curious way to go to
It's
market.
an interesting head fake, speaking of head fake. Yeah, I don't know, it's kind of water on the bridge at this point, right? So I think everybody's playing, it's interesting to see how they're reacting, because I didn't bring this slide back up for that, but I mean, it was a real shot to Google's bow, right? I mean, they really hadn't innovated in search in a long time, right? They were just milking that thing, and it's really interesting now to see that something like that would come out and change everything, but, so by the way, this is a Mario Super Smash Bros. Kind of reference, so, I don't know, my son plays, it was like Mario joined the battle, Luigi joined the battle, so I thought it would kind of.
Resonate with the young kids,
Yeah.
the hip kids nowadays. Mike used to be with it, but what he was with is no longer it, and what's it is no longer what he's with.
I believe it.
Thank you very
Thank you.
much. Thank you. Okay, so thanks for dealing with the projector issues also. Jason's got a live demo that he's going to go through and do as well as part of this with his ICD-10 codes that he's doing. So if the projector doesn't work or whatever, we'll try to accommodate as we're going through that component of it. But after we do this, we will go through and do the raffle for the items. And then also there was a reminder that I was reminded to do, and I forgot what the reminder was.
So if you entered after we were doing registration, just come and see me so I can get you in our list and
Yes.
you can receive follow-up communications. So
And
my
be
name
part
is
of the
Karen,
raffle.
I'm with Mantium, so come and see me if you have not registered yet.
Excellent, thank you,
Or
Karen.
registered or signed in, whatever.
Right, maybe Jeff's here.
Thank you. And also, please come and eat some more pizza.
Yes, please eat the food. Okay, so we'll pass it over to you, Jason. You want the microphone, or are you just gonna talk and talk?
I think I can talk. Is that loud enough?
Yeah.
Cool. I think the projector is showing.
incorrect. When I got here, it was on the whole touch when I tested. And now it's looking at it. I broke it. All right, so tonight we want to do a technical, more of a technical talk, but I want to hopefully demystify some of the complexities for those that aren't familiar with some of the technology underneath how some of the generative AI works. I want to focus specifically on the retrieval augmented generation.
I go by Albert.
Thanks for referring to that. Mike saying I wasn't going to go too deep, but I didn't, because that's what I'd be embarrassed. As we would have the same material. And then I wanted to show an application of that in the healthcare space using ICD-10 codes. So a little preface, I am not a data scientist, I'm not an AI engineer, and I am not a healthcare professional. So this will be fun. What I am is the CTO and co-founder of Mantium. This is the second startup I've co-founded with Ryan Seavey, who helped found this meetup. And we also founded Nexosis together. We were acquired by Data Robot, where I was the VP of Enterprise Security and Product Security there. Before that, I was a principal researcher at Veracode, a cybersecurity company, doing binary static analysis, dynamic analysis on software, finding vulnerabilities in code. Before that, AEP principal cybersecurity engineer, so on and so forth. A lot more behind that, but I don't need to get too deep into that. But I wanted to talk about retrieval augmented generation. And sort of some of the ways we can build these systems, how we can use them, and how they help solve some of these problems with hallucinations and other things. So this was a paper came out from some people who were at Facebook, now Meta, in 2020. And they wrote how you could basically use retrieval augmented generation for knowledge-intensive NLP tasks. Still a mouthful. So I hope by the end of this, while you might not follow everything, I don't either, it's okay. As long as we get the big picture and how it works, I think that can really enable us to help innovate, think about how we can build applications that we can use. So these large language models, LLMs, are incredibly powerful, but they have some limitations. And in the first sort of few iterations of Mantium, when we were figuring out exactly what we were going to do with in the large language space, we spent a lot of time with large language models. We decided to try to train our own. Challenging, very expensive. And some of the challenges we ran into is there's no external memory, right? It's all baked into the model. All of its memory is sort of embedded and static. There's no straightforward way to provide insights into predictions. How did you get that answer that you just spit out? You can ask it, and it kind of can illuminate that a little bit, but it's not great. And they're likely to produce hallucinations for this reason, and you can't really get to the bottom of that. So RAG, which is a terrible acronym, but that's how it works, attempts to address some of these points. With retrieval augmented generation, knowledge can be directly revised and expanded. So without retraining the model, without fine-tuning the model, we can effectively give it information it did not have, it is not trained on. And since it has a great understanding of language and a lot of other topics, it can then augment its knowledge and expand and espouse real information based on accurate facts if that source of data is true also, right? So we still have to follow the trail, make sure our data is good, it's not biased, etc. Right? All those things apply here too, as well as they do in the foundational model. So if we have systems that store data we collect from customers, employees, whatever, we can leverage that here without actually shipping all of our data into a model or fine-tuning a model at OpenAI or some other provider or spending all the effort to build our own model. And with this, you can actually access that knowledge that it retrieved, and you can inspect it to check the source, right? So it generated some things based on what it retrieved, and then you can review it. You can actually bring it up next to it and say, oh, that's where the model got it, and that's why it generated this. And it keeps it on track a little better. So let's try to define this a little more closely. It's effectively for language generation tasks, and this is sort of their conclusion in research. We find that RAG models generate more specific, diverse, and factual language than a state-of-the-art paramedic only, blah, 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 whatever, buzzword, technology, AI, baseline. Again, we don't have to understand all those details to understand that they got better, accurate, factual information. That's the takeaway point. And so I'm sure you've all gotten this message in OpenAI, I'm sorry, but I don't have real-time or post-2021 information. It stopped, it doesn't know anything after that date. Whereas other models that do retrieval can go fetch a web page. They can learn about what's going on, and then they can embed that into the current generation of what the model is output. And it helps solve this problem. And so systems like Bard and Bing, how they have integrated ChatGPT into their search interface, only if you use the Edge browser with it, you can actually see this in action, and it's pretty cool. So real quick, I want to cover just sort of the underpinnings of technology and some of the terminology you'll hear, and hopefully that'll get us all thinking about how we can innovate on this technology. Feel free to interrupt anytime with questions, I don't mind. Or corrections if I'm wrong. I'm wrong sometimes, that happens. All right, let's get into it. So vectors are effectively a primary data type used to encode or embed real-world information. In this specific context, we're going to be talking about written text. There are other methodologies to encode pictures, audio, and video. You've seen all that and how all that works, I think, with other systems like Midjourney and the like. It's really impressive how audio and voices can be mimicked as well. All of these use different types of embeddings and vectors effectively to get the work done. All of these deep neural nets and large language models effectively are storing a lot of this information this way. And so they enable the storage, querying, and retrieval of data in a form, it's basically arrays of floats. And we looked at your sort of your graph about GPUs and how they operate on floating points and why it's so fast. That's why we like GPUs to do this work, is that's basically the primary data type we're using in a lot of these situations. And we're dealing with highly dimensional data, incredibly complex data. So what is highly dimensional data? Let's talk about people and health, right? If I talk about a person and you're 6 foot tall, cool, not very informative for most. It may be interesting to some, but that's about it. Add weight, now you can start doing simple things, simple calculations. You know a little more maybe about someone's health, but it's still a pretty big swag. You start adding more and more dimensions, it gets more complicated, but you can build a better model of what represents a person and maybe a health profile. You can start to reason about the relationships between these things. You bring in family history, things get really highly dimensional. People don't think that way. It's hard for us to reason about highly dimensional data. Because there could be an almost infinite number of dimensions you can bring in. So if we're looking at the visualization of a neural network, of an embedding of all the folks on Wikipedia, you might see, if you try to render it and try to understand it, something that looks like this. Now, I can't really make sense of it, but it is fun to play around with. And you can see what things are nearer to other things. And that relationship really helps us figure out how retrieval and how vectors search work. And that's really what I want to get into is, we can't deal with this level, but these neural nets love this stuff. And they eat it up, and they're really good at it.
You have a question?
So here's some challenges with it. I think we can already understand why that's a hard thing to follow.
You have a question?
The question?
Yes,
Yeah.
go ahead.
So just make sure I understand, is RAG just, I'm not to oversimplify, by the way, is RAG just the retrieval of information from a vector database or some other type of vector storage using an LM?
Basically, we're gonna go even deeper. So,
Okay, I just didn't know, I just wasn't sure if that's what we're calling it.
That's right, yeah. So let's talk about how we get, oh yeah, go ahead.
This might be a little pedantic.
Sure.
But doesn't retrieval augmented generation not just require retrieval through a traditional search engine, but even something like if you sent out a survey and then you got survey results back and you used a large language model to give you sentiment to the survey, that is technically still retrieval augmented generation.
Sure.
So it doesn't have to be retrieval just from something in a vectoral database.
Yeah, no, not necessarily embedding.
Any retrieval of any kind, and then you
Yeah.
just add more detail to it with AI.
That's fair.
Yep, yeah, thank you. That's a good clarification. I will be talking fast in generalities. Feel free to weigh in if you have an interesting point to add. So how do we get to embeddings? And so to store real-world data for generative AI in the way that you might want to take a large knowledge source and make it available in an efficient, fast manner for retrieval, we want to get these into a thing called an embedding, which maps discrete objects. In this case, we're talking about words and phrases, to continuous numerical values, which are just these big arrays of floating point numbers. And to do this transformation, there's basically 3 steps. at a super high level. In these, each one of these, you can go really deep, but I think for the level we're talking at here, we want to keep it really high. So let's talk about data preparation and pre-processing. Unstructured data comes in tons of forms. And so this is a big challenge of this, and I think this has been the problem with machine learning. This has been the problem with data science all along, is there is a lot of data bunging, a lot of parsing, a lot of processing, a lot of how do I get the data in the right shape? Do I get rid of these things or those things? Do I leave the HTML tags in? Do I take them out when processing a web page, etc.? So there's a whole bunch of things here you might need to do, such as file format conversion, text extraction, so on and so forth. I'm not going to go into details here, but there's a big pile of information you should go into there. I've built actually a few of our data ingestion processes in our system to pull in data and run it through our whole process in our platform. And you sort of have to look at every data source uniquely. You have to make these decisions almost in every place. And I think with AI, sort of looking at these, they're actually sort of being able to do this stuff for us now. And we don't even have to write some of the code or make some of the decisions because they're starting to put that information in the models, so we don't have to worry about it, which is really nice. All right, so we're going to take, so second step was tokenizing. So that's effectively taking, in this case, a really simple phrase, and the tokenizer, tick token, is actually what OpenAI uses for GPT models. They run it through the tokenizer, and it sort of figures out ways to slice and dice the words for the model to use. And they have a little sort of page on their website. If you go to their tokenizer and you want to look at GPT-3, for instance, using R50K base encoding, it's going to split up this 7 years ago sentence. It's going to tokenize it like that. So that's sort of like you do your pre-processing, you do some tokenization, and then it's going to do some vectorization or embedding, really, is what we call it. And what it's going to start doing is it's starting to build that multi-dimensional model of how all the words and ideas relate to each other. And that's that highly dimensional space that's incredibly hard. So to oversimplify it in a way you would never really do it to be very effective is you could say AI and models have a relationship. Models and AI have a relationship. Models have a relationship. Our models have a relationship, are fascinating. And all these sort of build up this sort of multi-dimensional relationship among all these words. So it's a target and a context word in this case. In the real world, highly dimensional, very complicated, yeah.
How does it relate those words? Is it just the space between them in the sentence, or is there some other mechanism?
Really smart people figured it out. So, yeah.
Summarize.
And proprietary.
I was going to say, summarize real quickly, it's positional encoding, so where the words are relative to one another, text encoding, so what the words actually are, and then I believe in the case of vector databases, dot product, so that's linear algebra to actually like get the difference between the two vectors that you're comparing, and that helps to determine similarity for where the embeddings are placed / retrieved.
Exactly, yeah, we'll get into a very high level of some of that.
Cool.
Thank you. Yeah, we're not going to get through any of that. It's just not worth it. It doesn't matter.
Totally fair.
So once we have our tokenized text, we're going to run it through an embedding model. So we have a neural net that does this and figures it out. So humans aren't doing this, right? And then we get this really fun thing that we can't make any sense of. But these large language models love to use it for vector search, which is what we're going to. And then finally, to talk about, well, what is a vector database? It takes the original source text, tokenizes it, you enrich, you embed, enrich, and then store it. So you might have some sort of document that has the original metadata, which is the original text. And then you might have a whole bunch of these arrays. And this is going to then be used in retrieval using this to see where it falls in place with other vectors. And then we're going to be able to then retrieve the raw text because it's stored next to it. And then we can actually see what it says. All right, so how do we do then semantic search with that? So it uses something called approximate k-nearest neighbor search. It's an algorithm. We're not going to go into the details, but here's an example of some sentences that are generated. You can see them sort of in this sort of highly dimensional space and how they relate to each other. So I searched for generated with. It generated an embedding of that and found all the nearest neighbors to it, approximate nearest neighbors, not exact nearest neighbors. And then you can see like, and it has sort of a score as to how close they are. Right, so we have, these sentences are generated with only a few tokens, generated sentences are hard to make, generated sentences are good but hard to make. So you're kind of seeing like, in this highly dimensional space, how these things are related. And that's how the lookup works. And these transformer models, or large language models, capture the semantic needs. That's what we call semantic search. It's how words are related. So if you type in king, you might see queen, prince, and monarch related. And that's pretty cool because keyword searching and regexes will never get you here. That's why rudimentary search engines were terrible, and that's why Google search was so good. But now everybody sort of has that power. So here's a little more detailed process of how you might put this together. So you have someone building an app. They're writing some code. They're building an app. They have some data pipelining. And they're going to pull in external documents. They're going to call to external databases, APIs. They're going to find ways to bring data in continuously, process it through these pipelines, take that prepared data, pass it through an embedding model. If you're using OpenAI, you're probably going to use Ada too. It's going to return the generated vectors. You're going to combine all that information together, and you're going to store it in your Redis vector database, for example. And that is the first half of the story. So on to retrieval augmented generation. So the RAG process looks effectively like this. So I type a question, what is the ICD-10 code used for the common code to sort of bring in the healthcare loop here, and right before the demo, this is where we're going to sort of show what happens. That's the question. The question has to also get embedded because we have to see how, when we do the vector search, what all the nearest things in the vector database are. So you type your question, it goes to the embedding model. You do your vector search, your vector database has algorithms built in. So it's kind of like if you write a SQL statement, it's kind of like that, only with lots of the math. It's a lot more complex, but it's incredibly fast. And it pulls back your top 10, top K, however many you choose, top 3, top 50 documents that match. Then you have a system prompt sort of within the system that's going to prompt the LLM on what to generate. So given the context below, answer the following question. If you don't know the answer, simply say you don't know. It's really important for you to tell it to say it doesn't know, because it'll hallucinate if you don't, even with RAG. It then embeds the question, what is the ICD-10 code used for the common cold? And then that document, context, top ones, you could put 3 documents in, you could put 5, however many you want to put in the context window. You would then do retrieval in the context window, and then this becomes your prompt to the generative AI. The generative AI now knows it has static information that was pulled from your data source that you can now feed to the model as accurate information. In theory, as long as your source is accurate, of course. Then it will generate a very simple answer. The ICD-10 code used for the common cold is J00, which is classified under the category of upper respiratory infection. ChatGPT-4 would then ramble on for about 4 more paragraphs. And I'm using the GPT-4 API back here. So the API is different than ChatGPT. ChatGPT has a whole bunch of prompting and system prompts and moderation and checks, and it won't tell you certain things. These are raw APIs when you're talking with the API in the back of OpenAI's or any other large language model. They are unfiltered. They will do crazy things.
Yeah.
You must put guardrails around them. If you don't, you'll end up with really crazy, inappropriate bots that people will use.
For people who can't access APIs, you can also mess around with these on the playground.
Yes, in the playground. Good call.
You basically get the same experience, but with a user interface that's easier to deal with.
So sort of using the rest is the other half of the diagram. So this is your user asking the question. You've got some sort of orchestration. You may have a different LLM agents. You may have different tools available, like Wolfram Alpha. Like if you look at the OpenAI plugin system in ChatGPT, it makes tools available that can do things that large language models are bad, like simple math. You could make a calculator tool available. So then a large language model will make a decision. Oh, they asked a math question. Let's ask the calculator tool that does real math. And then you could bring that into the response as well as the other parts of the system. So you ask the question, validation, moderation always on the way in, results, decision points, pass, fail, modify, throw out, lots of complexities here. Very important step. Then you pass that up to the retriever. It hits the vector database after it does the embedding. Here's the embedding model, step 5, and then over to the chat model to generate the answer. On the way back, it comes back through output validation moderation, because even though you didn't say anything crazy, the AI might. So you gotta do output validation. You gotta do moderation again, you gotta do classification, you gotta make sure it's on topic, all those things. You do that on the way in and on the way out. And then back to the answer. Any questions on that? Yeah.
How and when is the vector database populated? Is that?
That was the step here. So there's an outside process running continuously to keep that data fresh, or a one-time run. If you just have a knowledge source.
It's not upon the creation of the question, it's?
No.
Okay.
This is set up in advance. This is a sort of a back-end process, sort of data loading that you may be doing continuously as you're ingesting data. Or if it's a static data source, once it's full of information and it's good, you may not change it again. But you do have to do that first. And then, when people use it, this is already full of the data. Yeah, good question, yeah.
So for LLM orchestration, for this demonstration, what did you use?
Mantium, our product.
Okay.
Because it's fast. And actually, I did it 2 ways, and I'll show 2 different ways. So real quick, ICD-10 codes, if you're not in healthcare, too much, ridiculously brief introduction. I'm just gonna give you like a sentence or 2, just to set the context for what these are. It's a 10th revision of a classification system or a taxonomy for a way to represent and communicate disease, conditions, injuries, and other health-related issues. For example, there are a whole bunch of chapters and blocks and titles for different types of procedures and things you may do in a medical setting. That's about where my knowledge ends. Importance of the codes. And if you're doing insurance claims, you will sometimes see these as well as the payment and billing codes too. So they do kind of get near and dear to us when we can't get a claim covered because someone miscoded it, right? That may be an example we run into. Because they look at the billing code, and if it doesn't match the ICD-10 code, they're like, we're not paying for that, you shouldn't have got that procedure. That's how the insurance
That's
goes.
why ICD-10 codes work, right? It's the way the insurance company gets out of paying my bill.
Exactly. So then you gotta fight them, and then you gotta go back and be like, no, you miscoded it, it's mistake to pay. Yeah, anyway. There's some really good, important reasons to have this, we just described one of them, and to have them done accurately. Which means you wouldn't wanna use my system to do your ICD-10 coding. I did not do any of the data science validation, so you'd want a team to do that, and make sure your system is accurate to a particular level. But it's good for documentation, treatment planning, billing and coding, health insurance reimbursement, a whole bunch of stuff. How you might put R&D money for pharmaceutical and medical device companies if they're seeing a certain number of things pop up of a new whatever. They might invest money in that space or marketing in that space to sell more products, right? Capitalism. All right, so here's the demo. How are we doing on time?
Good.
We're good? Good. Sweet, thank you. So what I did first, just to run you through the process, is you would have to find a way to get your data into a vector database. And the best way I do this is through our system. So I'm gonna use that as a quick illustration point. So I added a data source of the ICD-10CM. And all that was I uploaded the 2 PDFs I downloaded because they're available on the internet. So I have a content type binary application PDF. The file name and the raw text gets scraped out of that PDF. Our system just does that. Yeah, and I could add more files. This is more of a manual sync because I just threw a couple PDFs in the system. Once I did that, I had to build, because that data is not ready to go in a vector database. It needs some pre-processing. So we talked about it. The one we already did was I extracted all the text. So that was the first step of pre-processing. The next step of pre-processing I needed to do
was I needed to normalize the text, because there's a bunch of outline symbols and white space and all kinds of other stuff. So in this case, I decided to lowercase everything, normalize white space, strip lines, clean white space, and clean empty lines. Some of this is trial and error. A data scientist will do a much better job than I will. But it's not outside of reach, and it works pretty well for general personal knowledge management or fun things I want to do, right? Then we have to split it into sizes that you can actually fit through an embedding model. So there's limits to how many dimensions of data. So you can't throw the entire PDF in at once. You got to slice it into chunks. So we segment it by word. Split length was 500 words. And then you do a sliding window overlap of 50 characters on each side. So you have kind of some overflow on each side of those 500 so the information is not too tight of a window. Again, there's some trial and error I did. I talked to my AI engineers. They helped with some input on that as well, and we figured that out. Good enough. We did not test it heavily or rigorously. And then we run it through a generate embedding process. And this runs it through text embedding Ada 002 is our large language model we're going to embed with. They have a max token length of 8191, and then I use my API credentials. And then I click save and run. And so now you can see we have a whole bunch of normalized, segmented, and then the embeddings are at the end.
It's just populated your vector.
It's just populated my vector database. And it also saves your embeddings. And again, this is it doesn't render all the data in the UI because that would be a pain in the butt. So this is just
all
a
13,000 vectors.
Right. This is an elided version that we show in the UI because it would just it's not useful to show people. And once I did that, I deploy it effectively, which makes it an API endpoint available to use it. And so I can then click go to Mantium Chat on this, or I could go to ChatGPT and we have a plugin you can use with Mantium. We find it's better to not have all of the guardrails that ChatGPT's put around their stuff. It seems to work a little cleaner. And so we can ask a question. I have one here. I asked ChatGPT what are some questions I should ask. So what's the ICD-10 code for type 2 diabetes without complications? That's hard to see. That's not the right way to zoom. It's kind of more visible, right?
I can see it.
Yeah. All right, so we can send that in to the system. We don't do streaming of data yet, but the ICD-10 code for type 2 diabetes mellitus without complications is E13.9. And I can do RAG and view supporting content, and I can go over here, and I can look at my source and see that it in fact came from my file I uploaded. And it also shows some other relevance. So you can use this information to help debug. And so these are those 500 character split windows on the right. So that's RAG right there. This is retrieval augmented generation. Yeah.
So I know with ICD-10 there are quite a few variations and modifications on a yearly basis. Sometimes
Yes.
things keep changing. What measures have you taken to keep that kind of real time? Because
Yeah.
it's got to be real time.
Right, I have not taken any measures. That's a great question, and yeah, if you were gonna implement this for real, you would probably have a back-end database in your healthcare provider, or you've purchased a system that does this already. People are gonna put this in their systems. There's already companies out there that do ICD-10 coding with AI. This exists already. It's built into a product. You could also do your own thing with it. Like this with your own data sources, but you have to find that source you trust that is up to date. And that's and I just uploaded 2 PDFs. When the next PDF gets published, I could upload those. Right? But that's very manual, not ideal for a real enterprise system.
But do you have disclaimers out on the website saying that this is version blah, blah, blah?
This is not public. This is in my private chat. Only if I log in. I'm the only one who can see this. This is not available for anyone else but me for this demo.
Right. Yeah, I mean, eventually, if you're envisioning.
If someone
this to
did,
be-
yes, they should. Well, they should actually validate it with their data scientists and AI teams, know what precision of accuracy it has, and publish all that information based on test data sets they run against it, you know, and things like that. So there's a whole bunch of rigor behind it. I have not done any of that. Someone implementing a system like this can use building blocks to do that, but they still have to do the input and output validation and all the testing around it. So that's a really critical part of building an app. And since that's not my space, I don't do that. I haven't built that. But those are things one could do.
Do you
Yeah.
also, sorry,
No, you're fine, go for it.
do you also see this being an integration with the current electronic medical systems? The only reason I ask is because healthcare has been my baby for a very long time, so.
Yeah, I ran into some companies just looking around that actually have already built AI to solve some of this. I don't know how they're doing it, if they've trained their own models. That may be a better way, since the data set's not that big. Maybe it's better to build on top of another model. I didn't really dig into that. It was really just to show, here's RAG and here's a healthcare use case. That's about it.
Thank you.
So the nice thing is with the client library, it's an API calls. You could build an app on top of it. Instead of a chat interface, you can actually pass data through. So I have pre-staged in my very bad bootstrap application that I wrote. I should not do front end. But I have the diagnosis: patient presents with suspicious mold, blah, blah, blah. It exhibits some asymmetry, some things you might see, hear a doctor say, or write down in his medical notes. The procedure is I performed a biopsy for a diagnosis. That's going to need an ICD-10 too. They also have a medical history, and it's good when you're unremarkable in this context, but most people don't like hearing that. And then so if I click this, and it's a little clunky and slow because I'm running this on my laptop here over the guest Wi-Fi, but I think you can see in my log here, and it'll take a second, and it'll render it on the screen, but just to show things are happening. Oh, of course it went down, the demo got through that. Yeah, let's try one more time. Test it before, and then you do it during it.
100% of the time.
All right, so there we go. So there's the retrieval of all the document slices from that data set that has all the ICD-10 codes. And then it's sort of passing it to the AI to sort of analyze, one, what the doctor's notes were, what the document says, and it's going to effectively map the two together without me writing any mapping code, which is pretty cool. Considering the product query, the findings suggest that the patient might be having melanoma of the skin. The relevant ICD-10 codes would be melanoma of skin, unspecified C43.9, melanoma of interscapular region, C43.59, as the mole is located on the upper left scapular region, which is what I wrote in here. It does talk about the upper left scapular region, so that's nice. Then it says, please note that the definitive ICD-10 code can be assigned after confirmed diagnosis from a biopsy result, so it's even warning me. So it did a little generation on top of that, because OpenAI's GPT-4 knows a little more about this than even I do, and it added some little warnings. But it says, for now, a Z12.83 encounter for screening for malignant neoplasm in the skin might be appropriate. Cool. Pretty neat. And then I can show the query at the bottom. So it rewrites all that data into a more succinct, compressed prompt. And then you can see that after the query, all of the documents retrieval. So here's another candidate. Retriever top 4, top K is 4. Here's a candidate. So that one got a 0.9, so that's pretty high match. And that was the document it returned. And you can see there's the second one with a score of 0.90, however many digits. So basically they're going to be match. So on and so forth. So it used that information. I passed all that into a final prompt to OpenAI, and it wrote this small little description. Any questions on that? Yeah.
I more so wanted to kind of piggyback off of the previous question in terms of I think you vaguely hinted at fine tuning and the potential applications for that. Do you see the benefit of fine tuning? Because my biggest concern is that given what was mentioned in the previous question about the data needing to be updated annually, I feel like fine tuning might be a bit too I can't think of the right term, but like involved, invasive, or prohibitive potentially, yeah, because of the cost, but also in addition to changing the weights of the model and potentially impacting how that data is then inferenced at a later time, so.
Yeah, I like using this method. In fact, our first sort of iteration of Mantium was to build a platform to help you fine tune. And it was such a pain in the butt.
Yeah.
And then we started to see, like, this was in 2020 as well, this paper came out, and we started seeing the sort of the space evolve, and we went, you know, we think we're gonna go down the RAG route it's not for everything, right? But it's a better, I think, and simpler approach to a lot of problems. And again, like you said, Mike, because you can build stuff, you do, that doesn't mean you should. I don't know if this is the best way to build an ICD-10 system, but it's just an example of how RAG works.
Well, it's certainly a predictable and consistent one versus the alternative of fine tuning and then hoping the inference is still correct. Even potentially some combination of the two could still potentially be questionable as well.
So.
Yeah, so we did a project that we use fine tuning. So we're in the PT space, physical therapy. So we fine tuned on clinical guidance.
Okay.
Because that's not something we would pass along to the phone.
Nope. Yeah.
Then we used RAG to pass along plan information, outcome information, some of that kind of stuff that allowed us then to build plans on actually for PT, based on that. But fine tuning was an important part.
Makes sense.
We needed all the clinical guidelines for the PT clinical guidelines and for our orthopedic clinical guidelines top of mind.
Yeah.
When we had the conversation about, oh, here's some plans, give us plans back.
Got it. That makes sense.
Here's the patient demographic,
Yeah.
information, give us plans back.
So the focus was on guidelines, not necessarily like actual like data that could potentially change more frequently. That makes sense.
Yeah.
Yeah. Cool, thanks for sharing. Any other questions? That's pretty much all I had. Yeah, what's up? You first.
So, maybe because I'm technical but not an engineer, this feels funky naive. This feels like if you were to build an application, like a production-ready one, there's a lot of heavy lifting, like a big, you're talking about, data science to validate the output, building data pipelines, developing actual data to be used, all that kind of stuff. All I've heard for 15 years in tech is agile, lean, small bits, do it iteratively, et cetera, et cetera. How does this new paradigm drive with that, completely contradict that?
Yeah, I think you probably pick and choose your use cases very carefully. You don't want to throw this at everything, which is tempting because it's cool. But I think there are use cases I've used it for personally that are great. You can take, like, just putting all your notes in here. Like, we have a Notion connector, and I can put all my stuff in Notion, and then it just every day it just re-ingests it all, diffs it, puts updates all the vectors, and I can ask it questions about my data. For my personal notes and like what happened, super useful. Or like Zoom meetings, you can ingest your Zoom meetings. It uses Whisper to do all the translation, and then you can say, what were the action items? Like you can vectorize it and then ask questions about the meeting. What were the action items? Things like that. Not perfect, but I don't need those to be perfect.
I would also add that it makes more sense to use a RAG implementation with a vector database when the data is significantly sized, because a vector database is kind of overkill for a lot of these scenarios.
Oh my God.
You'd want to have something like you could even use like a NumPy array, to be honest. Like just store the vectors in there, and there you go. You got your spreadsheet. Yeah, like anything less than like 1,000 or 10,000 like
yeah, we did
sheets.
that. And it was like it's just as fast, work faster to just leave it in memory.
Yeah.
Load it in a file. Like whatever. Yeah, 100%.
Yeah. So, but that question.
That's a good call.
Yeah, really quick. What vector database do you end up using?
Redis.
Okay.
Come on,
Wonderful.
you knew the
Hands
answer to
down.
that. Who sponsors this?
Just wanted to check.
No, we support others, and we support your own hosted, we support our hosted, it's kind of fun. We support Pinecone, and probably Let's Go.
John, plug your ears. It's just right.
I'm just. Yeah.
You talked about RAGs reducing hallucination issues. How does that have any effect on things like Mandela effects? You know, you have issues with large language models where they rate frequency more highly than accuracy, so you run into issues like if you search Google right now, the country is not supposed to start with letter K, it'll tell you no, because there's a bunch of jokes using Kenya for things
so.
Interesting.
Yeah, so it tells you there's no countries to start with K.
I don't know that. Does anyone here? Oh, yeah, do you have more on that question?
So,
Yeah.
is there a way to reduce vanilla effects and kind of, improve the quality of that, or is that mostly a question of what sources you're pulling in when you're doing the RAGS implementation? Like,
It's a good question. I'm not actually sure. I don't know, yeah. Anyone have?
Actually, you want to, okay, got it. I was gonna say, I feel like it's a combination of two. You kind of need to take a more multifaceted approach in that situation. I would personally want to try and address as much of the settings of the actual model, but just right out the gate. Like if we can kind of remove some of those restrictions or set up the data in a way, potentially on the other side of that, where you're not necessarily sending it in with something that we are already aware is problematic like that. So you maybe want to work it around. You could do a bit of prompt engineering as well for the initial system prompts. That's something at least that you can do with GPT-4. It's usually a bit more flexible than Bard has been with some of those restrictions. In general, I've noticed Google's models tend to be more restrictive just for my general usage. So your mileage may vary there. And if you can get away with fine-tuning can also kind of knock some of that out, but you do lose out on the overall generalization of the model. So it depends on the actual problem you're trying to solve with that model and what restrictions you're kind of hitting. But those are some of the things I've tried.
Nice. All right, we're out of time. Our cruise has come to an end. Justin.
Oh, I was just going to add.
Hey, Justin's already
I'll be here all week. Great job.
Yeah, great job, Justin.
No, I was going to add, Jason made it clear that, we are using the API, which takes away some of the guardrails that ChatGPT has. We are putting our own guardrails on it as well. We're not suggesting don't do any guardrails.
Yeah.
So I just wanted to make that clear.
Oh, yeah. Like we use the moderation endpoint.
Yeah, right. There's a lot of,
You can't
that
do
little
AI
block.
without it. So it's built into our system, so it has some guardrails, and we're building more capabilities.
I was about, those tools will be exposed in the UI and you tweak it. But.
All right, everyone, our journey has come to an end. Yeah, usually you just say get out, but in order to be polite, I say please get out. However, before we do that, we do have our raffle that's happening.